On today's episode, we are getting into the latest space news, including NASA and SpaceX are sending people to an asteroid, SpaceX fires a rocket into a showerhead, and Voyager 2 calls home after a tense 2-week dark period. This is the space race. NASA has updated a mission profile that will send astronauts to a near-Earth asteroid, and this time they are looking to use the SpaceX Starship and Falcon Heavy to get the job done. Back in April, NASA scientists pitched a new plan for a crewed asteroid mission at the 8th IAA Planetary Defense Conference in Vienna, Austria. It's currently just an idea, something NASA calls a notional mission. These are usually the first real stages in planning missions before the administration makes decisions on what to fund. The mission document proposes a 182-day mission where 3 crew members will head out to an asteroid in a stable orbit of Earth. But what makes this possible now is the existence of Starship. Original plans for this type of mission were drafted all the way back in 2014, but they involved SLS and Orion back when the Orion capsule was just beginning its testing phase. Now, since the need to visit an asteroid wasn't overly pressing, and SLS was very far from being functional, the mission was shelved. This new plan, however, comes just as NASA is starting to actually budget for sending crewed missions to Mars, journeys that will cover way more distance than a trip to one of our near-Earth asteroids. So, NASA techs saw the need for a test mission with a destination further afield than the Moon, as well as a very promising vehicle called Starship, and dusted off the old SLS mission for a rewrite. So here is how the current mission is designed. First, a to-be-determined number of Starship tankers and a Starship propellant depot will launch into low Earth orbit. The vehicles will dock once they are in a stable orbit, transferring fuel to the propellant depot until it is completely full. The last step of this phase is the launch of a crew-rated Starship, which will dock with the propellant depot vehicle and refill its LOX and methane tanks before lifting it into a very high Earth orbit about 113,300 kilometers above sea level. Next, the departure taxi. A crew-rated Falcon Heavy will take the 3-person team of astronauts into space in a Dragon capsule. The capsule will then dock with the crew's Starship, which is fully fueled and waiting in high Earth orbit, and allow the astronauts to climb on board before the Dragon capsule returns back home for retrieval. From there, the crewed Starship will initiate their transfer burn to engage the targeted asteroid, which for now is an object named 2001 FR85, but could change before the mission is fully planned out. The transfer will take 46 days, after which the crew will spend 16 more days with the asteroid. To get back and forth from their Starship to the asteroid, the crew will use an unpressurized operations craft, which hasn't actually been designed yet. They won't be needing much more than that because FR85 is only about 52 meters in diameter, about as wide around as the wingspan of a 747 airliner. After just over 2 weeks near the asteroid, the crew will depart aboard their Starship, heading back into high Earth orbit to meet another Dragon crew capsule launched by a second Falcon Heavy departure taxi. This capsule will return the astronauts home, while NASA decides whether to keep the crew Starship in high Earth orbit or return it to the ground for repairs and reuse. There's honestly a lot of questions that this mission plan brings up, but the most immediate one is why spend resources on going to an asteroid instead of just heading to Mars? Now, we touched on that a little earlier, but the reason is that getting to this asteroid is relatively easy compared to getting to Mars, but it makes a good test of the vehicles and systems we need to use for our eventual Mars missions. It's farther out than the Moon, so we'll have to use Mars-capable ships to get there. And the time aboard the vehicles will put stress on the crew in ways we can study without subjecting them to a full 2-year mission to the Red Planet. They'll be exposed to more radiation, more time being weightless, and less support from Earth. This mission will also let us test our communications network, which is only just now being upgraded with Mars missions in mind. And there's also some asteroid science we'll be able to do while we're out there, but that's honestly more of a bonus than something to aim for. NASA has been incredibly successful with their stepping stone style approach to spaceflight, and Mars might seem close, but it's quite a bit further out than humans might be prepared to operate, so it makes a lot of sense to plan for something part way in between. In the same way, NASA will likely make sure we are well practiced at sending people to Mars before sending astronauts into the asteroid belt or the outer planets after that. This approach is just safer. The really flashy part of this plan, though, is the use of Starship, its variants, and a crew-rated Falcon Heavy, all of which don't actually exist yet. Notional mission plans do this pretty often, but generally speaking, they only run numbers on vehicles that they can be reasonably assured will be operational by the launch date. This potential mission is tentatively planned for 2039, and a lot can change between now and then, but between the Artemis missions, the US Space Force contracts, and SpaceX themselves, there is a lot riding on the success of Starship. The future of human spaceflight is quite literally riding on this vehicle. On August 6th, the SpaceX team announced that they were closing the roads around Starbase Boca Chica for a static fire test of Super Heavy Booster 9. The booster has been standing on the orbital launch mount for over a week now, while various tests have been run on both the newly installed or repaired launch hardware, as well as the booster itself. The road closure was scheduled for 8 a.m. until 8 p.m. Eastern Standard Time, and in the first few hours, observers watched as the SpaceX technicians completed a partial fill of Booster 9 and a spin prime test using a small amount of fuel to activate the pumps that power the fuel systems feeding the rocket's engines. A brief lack of activity followed just afterwards, causing a few people to wonder if a spin prime was all we had in store for the day, but at about 3 p.m. the pumps on the tank farm started up again, and the booster began to fill for a static fire. A full fill wasn't needed, so it didn't take long before the deluge system activated, and all 33 engines on Booster 9 flared to life for about 2.5 seconds. The test was reportedly supposed to go for 5 seconds, but 4 of the booster's engines cut out at about the 2-second mark, and the team obviously decided to halt the test there rather than waste fuel. Other static fires would likely have gone ahead for the full 5 seconds, but that wasn't necessary here. Booster 9 has been fired before for one thing, and aside from some minor engine anomalies, it didn't really need this test. But the OLM sure did. Over the last couple of weeks, many SpaceX observers have documented the repair and construction work going on surrounding the launch mount. The quick disconnect was repaired, as was the gas prime system that feeds the engines, not to mention the pad itself with the new deluge system. These were the areas most in need of a test, and a 2.5-second burst from 33 Raptor V2 engines certainly did that. Sure, they likely weren't operating at 100% thrust, but all the OLM systems seemed to work flawlessly, especially the deluge system. Sorry to keep bringing it back to this, but just compare Sunday's test to other static fires from even just this past February. Debris and dust were kicked up and blown outwards in a huge radius, but on Sunday, the deluge system only caused some steam to billow out past the tank farm. Calling this a success is an understatement. We don't yet have specific data about how well the new steel plate took the beating from those engines, but it definitely looked a lot safer, and that's likely why this static fire happened so soon. Most folks, us included, didn't think we'd see a static fire until later this month, but not only does SpaceX need to use their time wisely, but the FAA is still finishing their investigation of the April 29th test launch that destroyed the launch pad in the first place, showing them that they have already dealt with the primary issue before the FAA has even given SpaceX a list of demands, should hopefully head off a lot of work standing in the way of the next Starship test flight. On August 4th, scientists finally received a signal from deep space. Voyager 2 was pointed back at the Earth. NASA reported that during a routine transmission with the craft on July 21st, a small mistake in the command lines accidentally told the probe to reorient a mere 2 degrees away from Earth. Now, that might not sound like much, but Voyager 2 is currently over 20 billion kilometers from Earth, so 2 degrees is enough to make sure NASA would be out of communication with Voyager until October, when a program would automatically update the probe's orientation back to Earth. So while it wouldn't necessarily have been catastrophic, not being able to communicate with Voyager for months would mean that should anything happen during that time, we would just never hear from the probe again and never know why. But after a bit of thought, NASA technicians used the Deep Space Network facility in Canberra, Australia, to send a shout command telling Voyager to reorient, not knowing if it would work. At its current position, it takes a signal 18.5 hours to reach Voyager, so it was a pretty anxious 37 hours before the staff received the good news. Voyager's heartbeat, a grouping of regular science and telemetry data, was picked up by the DSN, proving that the shout had been received and the probe was pointed back at Earth. Voyager 2 was launched all the way back in 1977 and had, along with its sibling Voyager 1, given us some of the first relatively up-close images of the planets in our outer solar system. Both probes had then passed through the Oort cloud, a shell of icy asteroids, radiation, and planetoids on the edge of our solar system, then even further crossing the heliosheath, the very edge of our sun's solar reach that astronomers use to mark the solar system's boundaries. We had only built the probes to last about 12 years, the length of their primary mission to photograph the outer planets, but they've been surviving on their radioisotope thermoelectric generators for much longer than that, as their technicians slowly shut off more and more of the unnecessary tools to ration power. Scientists have been using the remaining tools to run tests on our communication capabilities, as well as gather what little data the probes still can, as we've never had the ability to do so from interstellar space. Over the last couple of years, however, the Voyager team has begun preparing to shut down the final instruments, and by 2025, they estimate there won't be enough power to operate any scientific instruments aboard either probe. It is good to hear Voyager 2 again, but it's only a matter of time before it and Voyager 1 send their final heartbeats back home. After that, the probes will become wandering time capsules, the engraved golden records on their hulls pointing the way back to Earth for anyone who finds them. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long-form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.